Hello everyone. Today we are going to have a look at the Blackguard Information Stealer. I got a sample of this about 2 weeks ago and I uploaded some notes about it on GitHub, but now I want to go deeper into this. So I am going to provide you with the sample hash and the URL where I got this from in the description. Let's jump in and have a look at this information stealer. So first, I'm going to extract this. The password is infected as always, and then I'm going to put this on the desktop. It's got a nice icon here, pretty cool. Let's rename this, and we're going to call it Blackguard. So I have Flare VM installed, and we're going to go to the utilities folder, and there is Detected Easy, still one of my favorite applications. And I'm going to drop this in here, and then we will get a first overview of the binary. So we've got some .NET here, version 4, and we have this file type P32. If we take a look at the entropy, you can clearly see that the part up here has a very high entropy. We are going to have to take a look at that definitely. Now let's open up Commander to get a command terminal, and then we will just go to my user directory here, go to the desktop, and then we can run strings on the sample. Of course, as expected, there's a huge amount of strings in there. There's also this, which was pretty cool, this ASCII art here. So we got gold black here, that is maybe an indicator. But the problem is, as you can see, this just spams the terminal, and we can't read any of it properly. So I'm just going to go ahead and I am going to pipe this to, or redirect the output to a strings file. So we're going to just say strings.txt, let this run, and now we should have some strings in this file here on the desktop. So when I went through the sample the first time, I came down here, these types of strings. So you can clearly see that there's a pattern here. So for instance, there's always this H4S and these couple of A's here. And we're going to get to that later and see what that is. So of course, again, there's a lot of interesting strings in here. There's even here hello world. This post here is something that might be of interest. And lots more of these strings starting with the same pattern. So let's explore this in dnspy to have a look at the insights. And for that, I am just going to go to the .NET folder here in the Flare VM stuff and drop it into dnspy x86. So we have this decompiling here. I will just make this a little bit larger so it's easier to read. And over here we can see this soft. So that is the name that is in here that the authors chose. And here we see these references to Blackguard again. Let's start digging into this. So I'm just gonna open this up here, expand this, and it seems that the sample isn't obfuscated in any way. We can clearly read all of these names here. Let's start at the top. Just have a look at just to get a feel what we can find in here. So we get, for instance, AES. We have something here, FileZilla. We have NordVPN. We have Monero. We have Litecoin. So VPNs. This is just cryptocurrency. We have something called Screen. We have something called Sending, SQLite. So all of these seem pretty interesting. There's also Telegram in here. Let's maybe have a look at Chromium, Edge, Firefox. So let's do Firefox. We can see here there's something called Recovery. And this is where all of these weird strings turn up. And of course also this decrypt function. So if we take a look at decrypt, we can see what happens to these strings so that they are decrypted. So this isn't really hard to reverse engineer, in my opinion. All that happens here is this string is passed into the function. It's then converted from base 64, and then we get this byte array. Then we have some checks going on. This is a memory stream that's created, and then we have this gzip stream, which is just going to go ahead and decompress all of this. So what I did is I wrote a small Python script that will take in each of these strings and then perform this exact algorithm so I can deobfuscate the data that is passed into this decrypt function. And we're going to have a look at that in a second. To deobfuscate all of these strings that we're interested in, we are going to go ahead and do cat strings.txt. So that's all of the strings that we got via the strings command from the malware. We're going to grep for h4, and then we're going to redirect that to extract.txt. If I run this, we get extract.txt, open it up, and this first one, we can throw this away. That's not relevant. Save that, and as you can see, we got all of these strings in here. Now let's close this up and go over to Notepad++. Here I have this Python script that I wrote, which basically reverses, or which I basically wrote after reverse engineering this decrypt function, and it does exactly the same thing. So what this is going to do is it's going to create an empty list, which is called strings. Then it's going to open extract.txt and read all of the lines into strings. For each item in the strings list, so for each string, we go ahead and do the base 64 decoding and then the gzip decompression. And last but not least, we're going to print out the result as a string again. So if we go ahead and say Python, and then this dec.py, that's the file I just showed you, and run that, we get all of the strings in here. So let's just redirect that to, I don't know, let's call it decrypted.txt. And now we have all of the strings. So here's some indicators that we have: API telegram.org bot. We have this free geo IP. This is return most wanted. Okay, it's missing a D. There's a spelling error there. But we have everything that we found in the malware, and it's now nicely decoded for us. That is that, and I am just going to do a quick rewrite of this so that we can pass in a string, an encrypted string, one at a time, and just get out the decrypted version, and then we will use that to work our way through this sample. I just changed the Python script up a little bit. I imported sys up here, then we get the command line arguments, check if there's two arguments. If there are, we take the first argument, put it into string, then output that, and eventually just decode it and output the decoded output. So if we run this on one of the strings from the file, from the extracted strings, I called the program signal.py, we get something like this. It's just going to give us what we sent into the program, then this little arrow, and then here the decrypted string. So with that, we should have a little tool that we can use to make our way through the disassembled code. I thought we'd start walking through this malware with a small function to begin. And for that, I chose screen. So this is the class screen, and it's got the method getScreen. You can probably already think about things that this might be doing, but let's walk through it anyway. So first, it's going to get this chicken dir, and it's going to get that from help. So we go in here, and you can see that we've got something called stealdir, then these two backslashes for the path, and then we have genstring generate. Have to look at that, and of course system info, it's got comp name and system info username. This stealdir is put together up here. and you can see that we have what seems to be just a random string here. So we can click through those. This syspatch points to my documents, and if you look at this my documents, you can see that it gets this special folder personal. So we're gonna see that later when we actually run malware. So down here, if we go back, we now know that this chickendir is going to be the directory where the malware is going to put the information that it stole, and that it is going to exfiltrate. So we can discern that from here, at least from what we can see until now. Now this is pretty straightforward. It's going to take the width and the height of the screen and create this new bitmap. It is going to use copy from screen to take a screenshot, and then eventually it's going to save the screenshot to this exfiltration directory under the name here, which we're going to deobfuscate in a second, and it's going to save it as a PNG. So let's put that into our script so we can see what the string actually is. So I'm going to call single.py, put this in, and you can see it's going to save it as / screen.png. So that's the screenshot functionality. Next, let's take a look at this blackguard.firefox. We have a function run in here. There is the safe path, which is probably going to be the directory that we saw earlier in the screenshot function. And here, the malware is going to walk through all of these strings here in these paths. So they're all encrypted here, but they all appear one after another. So if we take the first one, for instance, put it into our trusty Python program, you can see I already did a couple of those here. Just throw that in, and then we can see it's temp.net browser chromium, then a version number, and 32-bit. So it's definitely some kind of a browser. Let's take the last one. So, and we can see it's Brave software, Brave browser, and user data. So these seem to be the paths where browsers store their data. And if we come down here to our file where everything was decrypted, you can clearly see this was the first string, and as they appear after another in the malware, or after each other, sorry, we come down here, we can see that these are just a whole lot of browsers and the path to the folders where the user data is stored. The malware is going to walk through those, and it seems it's going to steal the cookies, it's going to steal the history, and this PA is probably going to be the passwords. So for instance, this history, this string here, let's just deobfuscate that real quick. So it's going to write the history, and it's going to write it to text2 plus this, and text2 is the safe path, and a name, which is probably, or which is going to be this this text taken from up here, from all of these paths that we saw earlier. So if we take this and just throw that into the Python script, we can see it's going to save the history, the browser history, as history.txt. Now, of course, we could go on and take a look at all of these functions here, all of these classes. For instance, getFileZilla and everything. But I don't think that's the way to go here. Actually, I think it would be cooler for you to see this in action. So what we're going to do is we're going to run this malware. But first of all, I am going to close all of this. I'd say let's run this thing. Let's let it rip. So I'm going to press start here. I'm going to put a breakpoint at the entry point. So I just don't want it to run through or anything. I want to go to the entry point. So let's say OK here and run the malware. First of all, we come to the main function here. That's pretty nice. So we get a look at that. And then we can just step over these. It seems to be getting the time at the moment. And here we got something interesting. We got this if not file exists, help directory build plus config ID. So let's look at this directory build, and it says, okay, help my documents. So that's this up here. And this uses a library function that that is known. So it's going to take special folder, get folder path, special folder, and then personal. So this is going to be the documents folder, I think. And then it's going to take that, and it is just going to concatenate that with the string, decrypt it, and we get the string return most wanted. Okay. So from here we also had an ID, and that's pretty cool because this actually seems to be the configuration. So there is this ID, and up here we have some sort of a token. We're going to see that again later, but for now, let's go back. And also, it uses this get process by name. So we're just going to run. And this is pretty interesting because this here does a check. So it says, is dn spin run? So let's go into that. And it just returns this. And again, we have these obfuscated strings. So this is app data. And we can see dnspy. So it's actually checking if we're in dnspy or not. So if I step here, the malware will just exit. What we're going to do is we're going to restart the thing. And we end up here. So we're going to come down. And to actually get around this, what we're going to do is we're going to do a right click here at collection start, right click, and then we're going to say set next statement. So we're just going to skip this and jump right down here to the collection. So if we go into collection, so step into that is, we can see that here is where we are stealing stuff. And you saw a screen before, right? So this is the get screen function. We briefly just clicked on this FileZilla, get FileZilla. There's even a spelling error in here, just for protocol. And here we put together a string. And then finally, there is the send and the sending post. So this is probably going to be the point where we exfiltrate the data. There's also something really interesting I found in my first pass through this malware, and that's this config developer. So if we come in here, it says, okay, there's a config developer, and at the moment it's set to false. So if this is set to false, it just does the collection, and then it's gonna show this, and then the application is gonna exit. So we can come in here and actually go ahead, and I think we can change this. And we can say true here, I think, and we should be able to set this. So now we have developer true because we don't want to exfiltrate yet, we just want to step through. So let's go back and continue through here. So when I step through these, we can also go ahead and open up a new Windows Explorer. So here, just gonna go up this IE user, that's me, going to the documents. And as you can see, there's already been a folder that's been made. And if we come in here, it's empty. So this is probably going to be what we saw earlier, where it put together this random string, and then msEdgeWin10 is my machine, and then dot username. That's exactly what we saw before. So the malware is going to drop the files that it steals in here. Let's keep that in mind when we step through this. So we have this great report. Look in here briefly. Okay, we have here is this Firefox recovery that we looked at before. I don't think I even have Firefox installed on this system. I just threw Chrome on here, so we're going to look at the output of that in a sec. And also this chicken deer turns up. So here we have a get files function, it's gonna create a directory again, throw something in there. I'm not gonna decrypt this. I'm just gonna skip over it. But I think if we come in here, yeah, it's already made the directory browsers, and it's got the downloads text and the history text. So that's exactly what I said before, or what we saw before. It starts to collect data here and just throws the collected data into this folder. Now to this getFiles function, if we come in here again, you can also see this. So it's probably going to take everything that's on a desktop, all the links, the stuff that's in the documents, and then this user profile information, put that in here, and then we get the source. So let's just jump over that, look into the folder and confirm this. So yeah, of course, it's got everything from the desktop is in here, my pictures, my music, this Blackguard folder where I store the malware. We also have this Windows PowerShell that's also hanging around on my desktop. So we got that. Wallet start, so these are cryptocurrency wallets. It's also something that it's going to collect. Ethernet, this is doing reaching out to this GeoIP. That's also that we saw earlier, this URL. So this is going to get the current IP address of the machine that the malware is running on. Yeah, it's this freeguip.app XML. And I am just going to keep stepping here. Then we got this get screen, and you can see we get a screenshot of what I'm currently doing. So we were correct about that assumption. This is all of the VPN stuff. And this is something we haven't looked at the moment, actually. This is this get system. So here we get the system version, screen metrics, processor ID, country. So that is also something that's going to be exfiltrated, operating system information. Gonna go over that. And we are actually going to skip over all of this because I want to go here. And this is where a zip file is going to be created, and this is going to be exfiltrated. So again, let's do a right click on this line, and then we're just going to say set next statement and set the next statement here. So this is going to take this HWID, so hardware ID, processor ID, and then it's going to do the state log. So it's going to take the date, the current date, put that in here, and it's going to use that to create a name for the zip file. So let's jump. Then we're going to go over this, and we have that saved. So now it's created the zip, or should have created the zip down here. You can see the name that the file is going to have. So we're just going to jump over that. And here we run into an exception. Don't actually know why that is, exactly why I ran into that, but it shouldn't be a problem. Okay, so I had to restart my analysis machine real quick. Sorry about that. It is just that my license down here is actually expired. So sorry, Mr. Gates, big fan, but that's just how it is. So this machine shuts down every hour and shut down right in the middle of this analysis. So yeah. Good, so I'm at the beginning again, and just gonna jump over this. Of course, and we are back where we were before. Now here, we can step through all of these functions. Where the malware wants to store all of the data that it's gonna exfiltrate. Now if we try to build the zip here, we are going to run into an exception. That is a problem. So we actually land down here, and we don't really care about that. So that's why we're just gonna go up to this file name, and then we're going to say set next statement. It gets the file name, which is the file name of the zip. It can't read the bytes because this file was never created. So we're going to come down here to this URL string, because that is actually what I want to see. I want to see the URL that the malware is going to exfiltrate to. Now, this is a big string. It's going to be put together with a lot of information in it, and eventually it's going to be sent down here. So all of the data, and as you can see, it also gets these file bytes. These are also going to be sent out. So the bytes of the zip. As you recall, this read all bytes function would have been used to read the zip into memory, and this is then passed here to the exfiltration. Let's just go ahead and do a step here. Step over this creation of the string, or this concatenation, and we come down here. So that's it. Either we're a developer, so if this developer in the config is set, which I have set to true, no exfiltration is going to take place, and the program just exits. If this developer is set to false, then the data is going to be sent out. So that is that, and down here we can actually see the string that's returned as the URL, and that is what I wanted to get to. That's what I'm interested in. So I'm going to take this, just copy it out. Passwords, cookies, history, as we saw, they actually got something here from the history because I have stuff in my browser history of Chrome. And then they also have cards, which is probably going to be credit card data. This IP up here, as we saw before, failed, and we got the Windows version running. That's the browser information. So they are exfiltrating as can be seen here via this API telegram.org. So it's going to be a Telegram bot. They have an API token. This token can be found here in the configuration. So this is the token, and this is the chat ID. So here in the back you can see that chat ID. Oh, so open the link. Just a sec. Here is the chat ID, and that can also be found in here. So the configuration is actually readable and not obfuscated in any way. Only all of these strings are. Here is a screenshot. I got this from Export blog on Twitter. So you can see that we have the Blackguard Stealer here advertised in a forum by this user blackteam007. There is the description that I can steal these wallets, Steam, Discord, passwords, cookies, autofill, and history from browsers. Then additionally, another resource was this securityboulevard.com, where you can also see a case where data is exfiltrated, just like we saw in the malware via the Telegram API. Again, there's this bot here, then you have the token, the API token, and the chat ID. So in this case, this was code injected into WP login PHP, so on a WordPress site, and the information to be exfiltrated is put together up here, stored in this variable, and this is going to be sent out in this key value pair, where the key is text and the value is the data to exfiltrate. This sample didn't have as much obfuscation in it as expected, and that is actually why I wanted to showcase this. I think it shows pretty nicely the capabilities of an information stealer, a little bit of the inner workings. It also shows a way to exfiltrate the data from the victim, and I think more or less, at least for me, this was a pretty interesting little tour, little reverse engineering tour. So with that being said, I thank you very much for watching, and I hope you had a good time too. So I will see you around. Goodbye.